Hey peeps, it's Sophie here with Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with physical sciences, and it's the 2018 grade 12 past paper, and this is a question on internal resistance and EMF. Okay, it says learners perform an experiment to determine the EMF and internal resistance of a battery using the circuit below. The learners use their recorded readings of current and resistance together with that equation to obtain this graph over here. So we can see that on the x-axis is 1 over current and the resistance is on the y-axis. You can see from this formula here the reason why it's 1 over the current. Okay, so the first question says which variable has to be kept constant during the experiment? And we know that we're finding resistance by changing current, and something that can change resistance quite drastically is temperature. So that has to be kept constant to ensure accurate readings. Remember, your ambient conditions must always remain constant. Okay, so going on to 9.2, it says refer to the graph. And the first thing says write down the value of the internal resistance of the cell. Now this is the resistance of the battery cell where there's no current flowing through it. So we can see here that the part where the straight line graph crosses the y-axis on the negative side, that's the internal resistance. There's no current flowing at that point. So that's about -3 on the graph, but it's just 3 ohms. You can't have a negative resistance, so 3 ohms. Okay, great. So 9.2.2 says calculate the EMF of the battery. Okay, so the EMF of the battery you can see is kind of the slope of the curve when you think about it in a straight line curve sense. From the formula there you can see. So R is the Y value, 1 over I is the X value, and if you put it into the Y is equal to mx plus C formula, you can see that the EMF is the M term, it's the gradient. So if I pick just a few random points on the straight line graph to calculate the gradient of it, so I can say, okay, I'm going to pick the 1.5 and about 7.5 there, and I'm going to pick the 3 and 0, -3 and 0. So we know that that is the change in y first, so that's 7.5 minus -3, because that's the point on the graph, we don't keep it positive. And then the corresponding x is 1.5 and 0, and then we can work that out to be 7 volts. Okay, that is the EMF of the battery. Great, you could also use the formula given, and it should give you the same answer if you plug 7.5 into the R term and 1.5 into the 1 over current term. Okay, perfect. Oh, and obviously -3 into the internal resistance. Okay, so that's it for this question. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. You can also be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until the next time, stay epic.